All right, good evening, everybody. Very nice to see you all on a nice summer evening. I'm so excited to introduce Dr. Hardy here with us. Dr. John Hardy graduated in dentistry from Glasgow University in Scotland. Shortly thereafter, he established a private practice in Victoria, BC, and a few years later, he entered an intensive general and anatomical residency program at Western University in London, Ontario, with graduate studies in virology and immunology. So he qualified as a consultant in oral pathology with subsequent hospital-based appointments in Ottawa, Vancouver, Saudi Arabia, and Northern Ireland. And in the mid-1990s, he represented Canada at the Centers for Disease Control, the CDC, in the USA on issues relating to HIV/AIDS. And this resulted in an interest in how infectious diseases are transmitted among healthcare workers. He has lectured on this and related topics throughout the world and has published more than 200 articles on similar subjects. And we cannot have someone more relevant than this in the times we are in today to talk about the concepts of disease transmission. So I welcome wholeheartedly Dr. John Hardy. And the best part is that Dr. John Hardy will be giving 2 more lectures subsequently. So the next 2 weekends, next 2 Mondays also with Dr. Hardy. So thank you so much, Dr. Hardy, for your time and welcome. And over to you.
Well, thank you, Sarah. And I also want to introduce my daughter, Adele, who is helping me for this evening, since I'm not all that technically astute. So, Adele, if you could show the first slide, please.
Sure thing.
Yeah. So tonight, I'm very pleased that I'm being given the opportunity to speak to this group. I have decided that this evening we will discuss the 6 principles which govern the transmission of infectious diseases. Then we will follow next week with a discussion on the implausibility of the concept of asymptomatic transmission of an infectious disease. And then I will end up at the end of this month with a discussion on the limitations of the PCR and the rapid antigen tests. So that is what I hope to present to you in 15 to 20-minute lectures over the next 3 Monday evenings. Next slide, please.
Okay. One moment.
Good. So what are the 6 principles governing the transmission of infectious diseases? Next slide. Prior to doing that, I do have to revert to giving you some very simple definitions so that we're all on the same page. A pathogen is any disease-producing microorganism, for example, a bacterium, a fungus, a virus, or a parasite. Obviously, for the past 2.5 years, we've been concentrating mainly on one particular virus. A vector, on the other hand, is an animal carrier in whose body a pathogenic organism will either develop and multiply before it's transmitted to a human host. And a fomite is an object such as a door handle, a book, an instrument, a mask, that in itself is not harmful, but is able to harbor pathogens and act possibly as an agent for disease transmission. So with these definitions, we will look, yes, fine, Adele, go. We will look at the first principle of the transmission of infectious diseases. And the first principle is that there must be a sufficient dose of an infectious agent. So what do I mean by that? Well, in the laboratory, it is entirely possible to calculate the dose or the amount of a pathogen that is necessary to cause disease in an experimental animal. And that's done quite frequently. However, for obvious ethical reasons, it is not possible to determine the precise infective dose for a human pathogen. And different microorganisms vary widely in their ability to cause an infection. However, there are 2 factors that need to exist before an infection will occur. And the first one is that the pathogen, no matter what it is, it must metabolize, that is, live and grow and multiply in or on the host tissue. And this requires very specific pH levels, oxygen tension amounts, temperature, and nutrition and nutrients, which are very specific for that particular pathogen. And at the same time, that pathogen must overcome the defense mechanisms of the host, because this allows multiplication of the pathogen to continue until a critical mass of it is reached, which for that microorganism in that host produces overt evidence of disease. So that's the first principle, a dose of an infectious agent. Next slide. The second principle is that not only must there be a dose of a pathogen present, but there must be existence of a viable infectious agent or pathogen. Viable meaning that it has the innate ability to cause an infection. And most potential pathogens require, as I said before, very specific temperature, moisture, light conditions, suitable nutrients, pH levels, in which they can develop and grow. And we call that the fertile soil for that particular pathogen. For example, if we have a bacterium that grows in our skin, it requires entirely different nutrients and a different fertile soil than one which would be growing in our gut. And if we take an organism on our skin and put it into the gut, it simply won't grow. It's not a suitable environment for it. So all pathogens require in their new host a very specific fertile soil. And leading to that is this concept of a fomite, such as a door handle, that does not provide the environment to sustain the viability of, for example, the hepatitis B virus. However, in the artificial environment of the laboratory, you may take a sample from that door handle and grow it in a particularly nutrient environment, which effectively resuscitates the hepatitis B virus, which may then go on to cause an infection. But that doesn't imply that the door handle had a live virus present on it. And sometimes people think that such things as glass shields, as masks, can actually produce an infection. But unless all pathogens have that peculiar, specific, fertile soil, which is specific to that pathogen, it cannot become viable. Next slide, please. So we now have an amount of an infectious pathogen present. We have one that's live, that is multiplying vigorously. It has to get outside the body before it can possibly contaminate someone else. So it needs a mode of escape. And what is that? Well, a pathogen prior to invasion of a secondary host must escape from its primary host. And human pathogens leave the body from the respiratory tract, through fecal material, and via body fluids such as blood, saliva, urine, and semen. So those are the major routes, in fact, the only routes by which a pathogen can come out of our body and potentially go infect someone else. Next slide, please. So we now have the pathogen outside the body, but it's got to have a means of transmitting it to the new host. So once a viable pathogen leaves a primary host, it must be transmitted to a secondary host before the potential for infection exists. And there are four principal routes of transmission. Physical contact, prime example being infectious mononucleosis, which is usually called the kissing disease, or most sexually transmitted diseases. Through the air, such as tuberculosis or streptococcal pharyngitis when we complain of a strep throat, or COVID-19. Through food and water, which is the fecal-oral route, and examples of that will be salmonella and cholera, and then indirect contact via vectors, which I mentioned before, the prime example of that being malaria. However, you can expand that definition a little bit and include hepatitis B circulating in the blood of, say, a drug user, which is then injected into another drug user who then acquires the infection. So these are the modes of transmission by which that pathogen can possibly get into a new host. So let's go to the fifth principle, Adele. So we now have the pathogen being transmitted to the new host, but it has to have a portal of entry by which it can get into that new host. So the potential for infection does not exist unless the transmitted pathogen enters into tissue, which for it will be fertile soil. Remember that concept I stressed at the very beginning. And that environment will provide it with its essential nutrients, allowing it to replicate. So the usual portals of entry are fresh breaks in the skin or in the mucous membranes lining the respiratory, gastrointestinal, and urogenital systems. So now we've got the pathogen perhaps in a fertile soil. What happens next? Next slide, please. Well, obviously there has to be a susceptible host. The ability of an invading viable microorganism to cause disease is dependent entirely on the susceptibility of the potential new host to that particular microbe. And the susceptible factors are general malaise, poor socioeconomic and living standards, chronic disease, increasing age, frequency of previous infections. But we can resist that. We can increase our resistance to those pathogens by having a healthy lifestyle, a balanced diet, and appropriate vaccinations. And it's a simple common sense truism that a young physically fit person will be much more tolerant of high numbers of virulent pathogens than a frail elderly person with diabetes or other comorbidities. Next slide, please. So what are these 6 principles again? They are sufficient dose of an infectious agent, the existence of a viable infectious agent, a mode of escape, a mode of transmission, a portal of entry, and a susceptible host. If one of these is not present, the potential for infection is reduced. However, the risk of transmission occurring can never be reduced to 0. And you may remember those stories of little kids who are severely immunosuppressed, they're undergoing bone marrows and they're encased in a bubble in an attempt to prevent anything from getting to them. But we just never know whether we can absolutely guarantee an absence of a risk of transmission. Next slide. So I would like, although I've identified these 6 principles, it's important to appreciate that each of the 6 principles is subject to a variety of influences: age, physical and mental health, socioeconomic status of the individual, and that they are not strictly defined inflexible concepts. They have a degree of flexibility. For example, throughout a lifetime, an individual will experience a variety of situations that will favor or not favor the transmission of an infectious disease. What the principles do, however, is they assist in identifying the numerous obstacles that potential pathogens must overcome to satisfy their disease-producing potential. And a very simple concept, or a very simple way of trying to understand this, is to look at this formula in which infection equals the virulence of the pathogen, that's a measure of its viability, multiplied by the amount of it, divided by host resistance. Next slide. No. So I got at the top that formula. And the formula identifies two aspects that are relevant to the transmission of infectious diseases. One, the infection is not an inevitable outcome of exposure to a pathogen, but depends on a spectrum of interrelated factors, which I have tried to indicate to you going over those 6 principles. And the second point is that the host resistance might be more relevant to the development of an infection than are the specific characteristics of the potential pathogen. Therefore, public health ought to be vigorously promoting healthy living, and not what it has done for the past 2 years is to separate us into isolated little cells, keeping us from going outdoors, etc. That's not improving our host resistance. So I firmly believe that one of the major ways we can prevent the transmission of infectious diseases is to increase our host resistance to those diseases. Next slide. So the transmission of an infectious disease depends on a unique set of circumstances relating to both the pathogen and the potential new host. And there was a fantastic book by a medical historian who's quite well known called Mary Dobson of Cambridge University. And she published an excellent treatise in 2007 called Disease: Extraordinary Stories Behind History's Deadliest Killers. It's a relatively easy book to read. But at the beginning of it, she says the following about infectious diseases. There is always a set of interrelated biological, genetic, environmental, and social factors, meaning that some people are susceptible and will succumb to the disease, while others survive or remain untouched by the circulating pathogen or a potentially fatal disorder. And we know this. We know that in any infectious disease, there will be some people who will not affect at all, and others who it will kill. And a major factor in that is host resistance. Next slide, please. So what are the takeaway messages from this brief talk? Well, first, exposure to a pathogen is not synonymous with infection by the pathogen. Secondly, a disease-causing microorganism has to overcome a number of obstacles before its potential for infection is realized. The most significant of these obstacles is the resistance of the new host. And the resistance is unique to that host, and it will change with time and personal circumstances. For example, I was probably much more resistant to many infections 50 years ago than I am today, just a concept of the aging processes. And finally, a personal risk assessment is an essential component of an infectious disease program. And I think this is something that has been missing when we talk about COVID and people's susceptibility to it. Everyone is going to have a different level of resistance to COVID, and therefore everyone needs to perform their own personal risk assessment and behave accordingly. So I hope this gives you an idea over the 15 or 20 minutes of some of the concepts that are underlying how infectious diseases are transmitted. And I thank you for listening.
Thank you so much, Dr. Hardy. That was so many beautiful things all captured in one small talk. And what I really like the emphasis that you mentioned, reducing transmission depends on host resistance. And the fact that that part was completely missing in our public health response. So before I let others ask questions, I'll be selfish and I'm going to ask you. So can a person who is not sick transmit disease to others? Because is it true that we all have some level of pathogens in our bodies at all times?
Oh, yes, we harbor bacteria, viruses all of the time. Absolutely. Right. That's a very interesting, the way you asked that question was rather interesting, because, and I'm going to discuss the concept of transmitting diseases asymptomatically. And I don't want to necessarily steal my thunder for next week's presentation.
Right. Yes.
But the way you worded it was, can you transmit disease if you do not think you actually have a disease? And yes, and an example of that might be, say, the sexually transmitted diseases, where someone might not understand what some of the signs of sexually transmitted diseases are. They may have ulcers in certain parts of their bodies. They may not really appreciate the significance of that and could transfer that disease without necessarily feeling all that ill themselves. So yes, that there can be instances where you could do that, but you've still got signs, although you may not appreciate the significance of those signs.
Yes, so I think what I was asking is that if I don't have symptoms that are very, very peculiar of a disease, I cannot transmit it to someone.
Well,
or can
the way I have always been taught is that before you can diagnose in a patient an infectious disease, they have to have signs and symptoms. They have to be ill.
Yes.
If a patient came into my office and said, well, what's wrong with it? Well, nothing, I'm fine. Well, they're fine until you know that they've got a sign or a symptom. So but I will discuss that more thoroughly next
week. Okay. All right. I'll let others ask questions. I don't see any hands, but I can end the recording at this point and people would be more comfortable asking questions. That